Welcome to Chapter 1, Lesson 8, on page 73. This lesson is called Slope. When you think of slope, you can think of a ski slope, and you can think about a mountain, and a person is starting at the bottom of the mountain and going up those ski lifts. You know, they have those little boxes, and you go up the little conveyor belt. They're rising up, waiting to go down, rising up. And while they're doing that, going up, they're also going across. They're running across the mountain. So they're rising and running across till they get to the top of the slope. So when you think of slope in math, you can just envision a ski slope, someone going up the ski slope, rising up and running across the mountain, then getting ready to launch at the top. Okay, so that's slope. In math, slope is the same thing, except it has to do with graphing points on a line, on a coordinate plane, and getting a line out of it. Okay, so let's check out how this works in math. Hero Comics prints on recycled paper. Oh, awesome. The table shows the total number of pounds of recycled paper that has been used each day during the month. Okay, so we have 3 to 36, 5 to 60, 6 to 72. Okay, my number spidey senses are tingling. I am seeing a pattern right here. 3 and 36, yeah, those numbers definitely go together. What times table are they from? Oh, I know. The 9 times table, or it could be the 12 times table. 5 and 60, that's definitely 12 times table. 672, oh, look, 12 and 144. Yeah, these all have to do with the times table, right? If you're thinking about ratios, this is what you're thinking about. Times 12, 5 times 12 is 60. 6 times 12 is 72. Times 12. My pen is just not working. Times 12. Okay, so this is an interesting pattern before we even get started. Okay, it says graph the ordered pairs on the coordinate plane. Let's zoom in here. Okay, so 3 and 36. Okay, so there's no 3, so you have to kind of go halfway. So maybe about here. And then we have 5 and 60. 5 and about 60. Then it had 6 and 72. So finally on the line, 6, 72, just a little below. 7 and 84. And 12 and 144. So 12 all the way out to 144. Following this logic, what would 10 be? Well, 10 times 12 would be 120. So the 10 would be right here at about 120. What would 9 be? 9 times 12 equals 108. So 9 would be, about 108. So you can see it's a line here, a linear relationship. It's proportional. Explain why the graph is linear. Well, that's easy. The ratios are proportionate. We learned that at one of our last lessons. Okay. Now it says use 2 points to find the constant rate of change. Okay, well, let's look back at our points. We had 3 and 36. Okay, good enough. Remember, the x is always first. And let's see, let's try 5 and 60. The x is first in line. Okay, now it says the change. This is really interesting because we had constant rate of change before. So change in pounds. Looking back to the graph, the pounds was These are the pounds. This is the y-axis. Okay, so it's saying the y part, this is the 36 and 60. What is the change? When it means change, it really just means subtract. Right? Change equals subtract. So change in pounds. Well, we went from 60 to 36, or 36 to 60. So the change between those two is 24, right? Think about 36, 60 minus 36, right? 24. Okay, now think about here we have the change in days. Days was the x value. So change in days, okay, 5 to 3 or 3 to 5 or 5 minus 3, that's 2. Okay, so the constant rate of change is 24 over 2, or of course we would put that in simplest form. So that would be 12 over 1, which is the same as saying 12. Interesting. Okay, so what's all this about? What's the purpose of this? Well, we're trying to find that thing called slope. I talked to you about the ski slope, remember, at the very beginning. So think about this as the slope in math. The slope is the rate of change, that constant rate of change between any 2 points on a line. Okay, when you think of slope, you can think of the change in y over or divided by the change in x. Okay, let's look at the definition. In a linear relationship, the vertical change in the y value per unit of horizontal change, which is the x value, is always the same. Okay, this ratio is called the slope of the function. The constant rate of change, or unit rate, these things we've learned before, is the same as the slope of a related linear relationship. So constant rate of change, unit rate, slope, they're all basically the same thing. Slope tells how steep the line is. The vertical change is sometimes called the rise, while the horizontal is called the run. You can say rise over run, just like we talked about, rise over the run. Rise over the run. So if you zoom in here, this is the rise, just like on our ski slope. Okay, the rise is going up. He's going up. And the run is how much of that mountain he's going, right? How far across it. Okay, starting down here, going up, 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 and he's running across it. That's the X part. Going up, going across. Rise over run. Okay, it says count the number of units that make up the rise of the line in the graph shown below. Okay, so the rise. So we're going up how much? We're going up 1, 2, 3. Okay, so the rise, we're going up 3. And the run, how far are we going? 1, 2. So the run, we're going over 2. So the slope of the line is 3 over 2. That's the slope. Rise over run. Okay, let's take it to a word problem. Pay close attention because the word problems in the book are going to look like this. The table below shows the relationship between the number of seconds, that's the y, it takes to hear thunder after lightning strikes, and the miles, x, you are from the lightning. Graph the data. Okay, so let's look at the relationship before we even look at the graph. 1 times 5, 2 times 5, 3 times 5, 4 times 5, 5 times 5. I think this is going to have 5 as a slope, if I'm going to make a prediction. Okay, let's just check. Okay, well, so we're graphing it. So this is x, so x is always first. So we start at the origin, 0, 0. And then we over 1 and up 5. Over 2 to 10. 3 to 15. Right? We can zoom in a bit. 3 and 15, right? 4 and 20, 5, 25. Okay, so let's look. We're rising 2, and we're running 2. Interesting. Okay, change in y. So let's change in y. Okay, so they're going to use these points, 5 and 25. And they're going to use these points, 15 and 13. So they're using these ones. Okay, change in y. Okay, this is the y. So from 15 to 25, subtraction, right, is 10. Okay, and then from 3 to 5, that's 2. So the rise from 3, right, from 3 to 5, if you look at it, was 15 to 25. Okay, so that's 10. And the run was 1, 2. And that was from 3 to 5, so that's 2. So 10 to 2. And of course, simplest form, 5 over 1 is 5, which was our rate of change, or our unit rate. Remember our unit rate? How much for 1? Okay, so unit rate, constant rate of change, slope, all the same. They're all showing you the same thing. So for every 5 seconds between a lightning flash and the sound of thunder, there is 1 mile between you and the lightning strike. That's interesting. So you could count, if you think about it, if thunder strikes or lightning flashes and you can count to 5, that means there's a mile away from you before the storm. So next time a storm hits, try to count between the lightning and thunder. It's pretty interesting. Okay, got it? Graph the data about plant height for a science fair project. Then find the slope of the line. Explain what the slope represents. So you have 1 and 1.5. Okay, so do 1 and 1.5. It's not going to be perfectly on the line. Look, 1 and 1.5. Okay, it's not going to be perfect. It's all right. 2 and 3. Okay, 3 and 4.5. Okay, keep going. Graph each point and then pick 2 points. Let's pick these because they're even numbers. It'll be easier to deal with. Right? So it's always the change in, remember, change in y. So change in y, plant height. So change in y would be x minus 3 over change in x, 4 minus 2, which equals what over what? All right. So finish this and finish graphing, finish finding the slope. Ronaldo opened a savings account each week and he deposited $300. So week 1, you can see halfway, 300. So that means week 2, 600. Week 3, 900. Week 4, 1,200. Okay, draw a graph of the line. So they did that. Find the numerical value of the slope. Okay, so they did from rise over run. So it's rise. So it would be 300. You're going up by 300. And you're going over 1 week. So 300 over 1 week would be the slope. Got it? So Jessica has a balance of $35. Okay. On her cell phone, she adds $10 a week. So after the first week, she'd have 35 plus 10. So that's 45. Right? Okay, so graph. graph the rest of this, and then think, what's the slope? What's the change in y, the change of the money, divided by the change in the number of weeks? Okay? All right. Don't be scared of slope. I used to be really scared of slope all the way up until high school, but it's actually not that big of a deal. Okay, I drew the drawing out before. This is my terrible version of a man skiing after I tried this one. So right here, put your little best cartoon of a man skiing. I'll be looking for this picture in class.